Today in class, we took a look at how we could use a logarithmic transformation to take an exponential data set and transform it into a linear data set. And what we're going to do in this video is take a look and see what happens if we don't start with data that is exponential, but rather start with a data set that is given by some power law model. But before we talk about the power laws, let's just do a quick review of what we were doing when we had exponential data. Remember that if we had that exponential data, then what we were doing in order to transform our equation was we were taking the logarithm of both sides of this exponential equation. So that would give us the log of y, which would be equal to the log of a times b to the x. And then also recall that the properties of logarithms that we talked about the other day allows us to rewrite the right side of this equation to be the log of a plus x times the log of b, where the log of a is, of course, the y-intercept of our linear equation. So here's our y-intercept. And then the log of b is the slope. And so this logarithmic transformation, again, is what allows us to take what is initially an exponential equation and transform it into the logarithmic equation that we end up with. So we're going to use the exact same principles to take a power model and transform it into a linear equation. So the basic form of a power model is y equals a times x to the p. Now notice that there's a slight difference here between the power model and the exponential model. In the exponential model, your variable is the exponent, and in the power model, your variable is the base with some other coefficient, or not coefficient, but some other real number as the power, and we're trying to figure out what that power is. So just like we did with the exponential model, we're going to take the logarithm of both sides. And just for fun, I'm going to take a natural log this time. It doesn't actually matter if it's a natural log or a common log, though. So then on the right side of the equation, we get the natural log of a times x to the p power. And we're going to use those exact same properties of logarithms that we used before to rewrite the right side of this equation. So we end up with the natural log of a plus p times the natural log of x. So notice this does look slightly different than the linear equation that we ended up with for the exponential model. Before, I'm going to get rid of some of this extra drawing that I wrote in. For the exponential transformation, we still get the log of y on the left side of our equation. But then over here on the right side, the log of b ends up being the slope, and x doesn't have a logarithm associated with it. That's not true when we're dealing with power models. In this case, we still have the logarithm of y over on the left side of our equation, so that hasn't changed. We still have the logarithm of a as our y-intercept. But this time, just because x was the base and not the exponent, this time our slope is p, the power, in our power model. And then we also have the natural log of x. So we're actually taking the logarithm of both our x and our y variables. So that is the biggest difference between using the power model transformation and the logarithmic transformation. If you've got a power model that you're starting with, you're going to have to take the logarithm of both x and y when you're doing the transformation. So that means that on your calculator, you're going to have the logarithm of x in one of your lists and the logarithm of y in another list. So I just want to do a quick summary of what we've seen in the last couple of videos. So what you're going to do when you're given a data set, of course you want to create the scatter plot to begin with. You're going to take a look and see if you can figure out what sort of model might be appropriate for scatter plot. If linear wouldn't be appropriate, then you need to figure out whether you think you might have either an exponential model or a power model. If you have an exponential model, then all you need to do to transform your data is take the logarithm of y. So you leave x alone, just take the log of your y values. However, if you think instead that you have a power model, then what you need to do is take the logarithm of both your x and your y values. Now, there might be times where it's hard to tell the difference between whether you have an exponential model or a power model. And then the question becomes, well, how do you choose, or how do you decide which type of transformation to use? And unfortunately, the answer is, well, you're just going to have to try them both out and see which one comes up with a reasonable linear approximation or a reasonable linear model for your data set. So that means you're going to have to do the transformations, run the linear regression, and then finally create the residual plot so that you can see if there's any pattern in the residual plot. Remember that if there's a pattern in the residual plot, then whatever model that you just constructed is not going to be an appropriate model for the data set.